In this presentation, we will show how data from building information models created by different disciplines can be imported and combined in Solibri Model Checker. Validation and conformance checks can then be carried out based upon the user's and/or project requirements. Solibri Model Checker is a platform-neutral, rules-based checking and validation tool. The data utilised to generate models for checking are created via IFC, Industry Foundation Classes, a model data exchange format developed and owned by Building Smart. IFC is an ISO international standard which the UK government sees as key to achieving its goal of Level 2 BIM by 2016. IFC models created can be imported directly into Solibri Model Checker. IFC is supported by over 150 software applications. For a full list of applications that support IFC, please visit the Building Smart Tech org site or follow the link on screen. On opening Solibri Model Checker, we are presented with the Recent Files dialog. The list provides quick and easy access to previously opened files and directory locations, either stored on your local machine or on your servers. You can identify the raw IFC files from the following symbol, whereas Solibri Model Checker native files indicated here not only contain data imported from the raw IFC files, but also processed information from the checking, communication, and interrogation-based functions. In order to validate a BIM model, we're going to import a number of IFC files that represent different disciplines. These can either be opened from a directory or by using the Recent Files list. In this case, we'll start with the architectural model. On opening, the model can be given a short name for report purposes later on, and we can check that the discipline is correct for the model type. If we now go back to the Files tab, we can add additional models to the project. Models can be opened individually from IFC files or all at once. If a model is already open, as in this instance, then any file selected will be added to the current model. Let's select the ventilation IFC files for the ground, first and second floors, along with the building structural model. Once the models are selected, we can click on the Add button, and the models are then loaded and combined with the architectural model. The combined data creates what we call a federated model. Solibri Model Checker provides strong visual feedback to the user. Hence, the first thing to appear once the models are opened is a 3D representation of the building model in question. It's worth noting that these models have followed a BIM execution plan, which should include a set of protocols and standards to ensure conformance to the required project geometry and data requirements. One such important requirement is that each of the imported models are coordinated about a single origin, allowing the correct positioning of elements in 3D space. Taking a closer look, navigation in the 3D environment follows the standard conventions for panning, orbiting, and zooming. The navigation map can be expanded and can be used by double-clicking on a location in the map to transport the user to that location in the building information model. Different data can be isolated easily by setting elements to what is called a selection basket. For example, we can select and view just the ventilation models and associated data. Likewise, navigating through the architectural model to the ground floor, we can isolate all the walls on that floor only. If we change the navigation structure to the class view, we can isolate all the walls. This now includes both the architectural and structural wall elements. Using some of the other visualization tools in Solibri Model Checker, the model can be sliced and diced to show the relevant part of the building in question. This can be carried out in multiple planes. The model can then be further interrogated by dimensioning between selected surfaces, points or edges. Markup tools can be used to highlight elements. This is not just a 3D graphical representation of the building. The model in Solibri Model Checker is a building information model that includes intelligent building elements. On hovering over any element, the automatic information pop-up displays key information. Selection not only highlights the element in 3D, but also displays the corresponding element attributes in the information palette. The information palette includes tabs for logical groups of data such as its identification, its location, its quantities. Selection of the area property clearly displays the associated value on the model. This can be seen again with the lengths for both the external and the internal side of the wall. Its materiality can be seen along with its relations. We can see it has a number of connections to other wall elements. Using the sectioning tool, we can see these connections to the other walls. The wall is contained on the ground floor. It provides the following space boundaries. It references the following rooms, and finally has the following number of voids that have been created in the wall. By double-clicking on one of the voids, we are now looking at information in relation to the opening. We can then navigate to the filling element, in this instance the window object. The data-rich information is retained from the IFC files, allowing intelligent, rule-based checks to be processed. We will see this in future presentations. The tools that we've demonstrated here play a major role in the selection and processing of BIM elements for future validation and extraction of data. In this presentation, we can clearly see how easy it is to import IFC data into Solibri Model Checker. We can also clearly see how model visualization tools can be used to enable clear communication of any issues which are identified during the checking process and for data interrogation. The next presentation, Model Checking, will use rule sets in Solibri Model Checker to validate data in federated models and to clearly identify problems which may otherwise only become evident once on site.